Throughout the universe, stars shine bright as celestial marvels, their brilliance fueled by an extraordinary process known as nuclear fusion. As we turn our gaze to the potential of this awe-inspiring phenomenon, we venture into the realm of clean and virtually limitless energy. Nuclear fusion, an awe-inspiring celestial dance of atoms within stars, holds the key to a cleaner and virtually limitless source here on Earth. This captivating process involves fusing light atomic nuclei to form heavier elements, releasing an immense amount of energy in the process. The allure of nuclear fusion lies in its immense potential as a sustainable power source. It generates no harmful greenhouse gas emissions, offering a climate-friendly alternative to carbon-intensive methods. Moreover, the fuel required for fusion, such as deuterium and tritium, is abundantly available, ensuring a nearly boundless supply. While challenges exist in harnessing this cosmic power on Earth, advancements in technologies like magnetic confinement and laser-driven inertial confinement show promise. As we venture closer into mastering nuclear fusion, we unlock the door to a brighter and greener future, where humanity can draw upon the very forces that illuminate the universe to meet its energy needs. The economic benefits of reliable fusion energy plants could be far-reaching and revolutionary, with significant advantages in terms of cost-effectiveness and a huge shift in the energy market. Once fusion technology is fully developed and operational, the cost of fuel for fusion energy plants would be considerably lower compared to fossil fuel-based power plants. Fusion fuels such as deuterium and tritium are abundant and easily accessible, ensuring a stable and cost-effective supply. This would reduce the vulnerability of energy prices to fluctuations in fossil fuel markets, providing greater financial predictability for consumers and industries alike. Fusion energy's inherent stability and predictability as a baseload power source could mitigate the price volatility often associated with renewable energy sources like solar and wind. While renewable energy can be affected by weather conditions, fusion plants would maintain a consistent output, ensuring a more stable energy market. The development and construction of reliable fusion energy plants would necessitate substantial investment in research, technology, and infrastructure. This investment could foster innovation and job creation in the energy sector, driving economic growth and advancements in related industries. As fusion energy plants do not rely on scarce fossil fuel reserves, they would enhance global energy security by reducing dependence on geopolitically sensitive regions for energy supply. This newfound energy independence could strengthen the resilience of economies worldwide and promote stability. Fusion energy has the potential to be deployed in various locations, including remote areas where traditional energy infrastructure is limited. This decentralization of power generation could enhance grid resilience, making energy supply more reliable during natural disasters or other disruptions. The emergence of fusion energy as a viable power source would create opportunities for new business ventures, from energy production to technology development, further stimulating economic growth and innovation. Countries at the forefront of fusion energy research and implementation would gain a competitive advantage in the emerging clean energy market. By exporting fusion technology and expertise, these nations could position themselves as global leaders in the sustainable energy transition. The widespread adoption of fusion energy would accelerate the transition away from fossil fuels, supporting global efforts to combat climate change. As governments and businesses increasingly prioritize sustainability, fusion energy can play a central role in achieving ambitious emission reduction targets. The environmental impact of reliable fusion energy plants would be transformative and highly beneficial compared to fossil fuel plants. Fossil fuel plants, such as coal-fired power plants and natural gas power plants, release substantial amount of greenhouse gases into the atmosphere when they burn fossil fuels to generate electricity. Carbon dioxide is the primary greenhouse gas emitted, contributing significantly to global warming and climate change. In contrast, fusion energy plants produce minimal to no greenhouse gas emissions during their operation. The fusion process involves fusing isotopes of hydrogen, primarily deuterium and tritium, to release energy. The primary byproduct of this reaction is helium, a harmless, non-toxic gas. Unlike fossil fuels, fusion does not rely on the combustion of carbon-based materials, hence avoiding the release of CO2 and other harmful pollutants. This inherent advantage positions fusion energy as a promising solution for curbing greenhouse gas emissions and mitigating the impacts of climate change. By transitioning from fossil fuel plants to reliable fusion energy plants, we could significantly reduce our carbon footprint and take a momentous step towards a more sustainable future. Moreover, fusion energy offers a unique edge over renewable energy sources like solar and wind. While solar and wind power are highly valuable and renewable, they are intermittent and subject to weather conditions. Fusion, on the other hand, promises consistent and reliable power generation, capable of providing baseload electricity without the need for fossil fuel backups. As we dig deeper into nuclear fusion, the societal impacts of reliable fusion energy become increasingly evident, offering a glimpse of the transformative potential it holds for human civilization. The realization of fusion energy on a global scale promises to shape a more sustainable, equitable, and technologically advanced future. One of the most significant societal transformations brought about by reliable fusion energy is the democratization of energy access. Fusion plants capable of being deployed in various locations would offer a path to electrification for remote and underserved communities worldwide. Energy poverty, a persistent issue in many developing regions, could be sustainably reduced, empowering communities to improve their quality of life and foster socio-economic growth. By providing affordable and reliable electricity, fusion energy would bridge the energy access gap, enabling healthcare facilities, educational institutions, and local industries to function more efficiently. The equitable distribution of energy resources would contribute to social development and create opportunities for people to flourish. The pursuit of reliable fusion energy is an endeavor that extends beyond energy production. It is a journey of scientific exploration and technological breakthroughs. The complexity of fusion research necessitates advancements in diverse fields, such as materials science, engineering, plasma physics, and superconductivity. As scientists and engineers strive to tame the power of the stars, their discoveries and innovations will reverberate throughout society. Breakthroughs made in the pursuit of fusion technology could have far-reaching applications, revolutionizing industries beyond the energy sector. This amplification of knowledge and technical progress is a testament to the far-reaching impacts of scientific exploration and innovation. Reliable fusion energy represents a challenge that transcends borders and nationalities, necessitating international cooperation and collaboration. The complexity and scale of fusion research and implementation call for a collective effort from the global scientific community, promoting a spirit of shared responsibility. The pursuit of fusion energy could foster new avenues of diplomatic engagement and international partnerships, as nations work together to overcome technical and financial challenges. This shared endeavor would strengthen diplomatic ties and engender a sense of unity in addressing global challenges. Geopolitical implications of reliable fusion energy are likely to be far-reaching, reshaping the global energy landscape and influencing diplomatic relationships among countries. The advent of fusion energy could have significant geopolitical ramifications. Fusion energy offers the potential for greater energy independence for countries that successfully implement and harness this technology. As fusion plants utilize abundant and widely available fuel sources like deuterium and tritium, nations with access to these resources could become self-reliant in meeting their energy needs. This reduced reliance on imported fossil fuels from geopolitically sensitive regions could lessen the potential for energy-related conflicts and tensions between countries. The ability to generate clean and virtually limitless energy domestically could mitigate concerns over energy security and strengthen a nation's resilience to external energy shocks. Countries that traditionally competed for access to fossil fuel reserves might find themselves cooperating more harmoniously in the pursuit of fusion energy, fostering a spirit of collaboration and shared prosperity. The widespread adoption of reliable fusion energy could significantly alter global energy trade patterns. Countries that have made significant progress in fusion technology could become net exporters of this clean energy, reshaping the dynamics of the international energy market. Traditional energy exporters may face challenges if demand for fossil fuels declines due to the rise of fusion energy. This could trigger economic shifts and necessitate diversification of their economies. On the other hand, fusion energy exporting nations would gain newfound economic leverage, potentially altering geopolitical power dynamics and shaping new alliances. The complexity of fusion research and the significant investment required could lead to an environment of scientific collaboration and cooperation among nations. The quest to master nuclear fusion is a daunting task that no single country may achieve alone. Consequently, fusion research could become a catalyst for collaborative efforts between countries transcending political and ideological boundaries. International partnerships in fusion research could pool resources, expertise, and funding, accelerating progress in developing reliable fusion energy. Joint research and development projects might lead to knowledge sharing and the establishment of shared facilities, promoting greater scientific exchange and goodwill among participating nations. Countries that lead in fusion technology might leverage their expertise and resources as a form of soft power in international diplomacy. The ability to export fusion technology, equipment, and expertise could enhance a country's standing in global affairs, strengthening diplomatic relationships and fostering goodwill. Fusion diplomacy might pave the way for diplomatic breakthroughs and lead to stronger ties between nations. Cooperation in the pursuit of sustainable and clean energy solutions could bridge political differences and promote a collective approach to address global challenges, fostering a more stable and harmonious international order. In conclusion, the realm of nuclear fusion unveils a breathtaking journey into the heart of stars, promising a future filled with boundless possibilities. As we explored the captivating intricacies of nuclear fusion, we discovered its potential to revolutionize our world in a myriad of ways. From its awe-inspiring promise as a clean and virtually limitless energy source to the profound societal impacts of equitable energy access and environmental stewardship, fusion energy beckons us towards a brighter and greener tomorrow. The economic benefits, technological advancements, and geopolitical implications of reliable fusion energy present an opportunity for nations to forge collaborative efforts and foster a spirit of unity in the face of global challenges. Embracing fusion energy is not merely an aspiration. It embodies a testament to human ingenuity, resilience, and our collective determination to address critical issues like climate change and energy security. As we journey forward into this realm of transformative potential, let us continue to explore, innovate, and collaborate to unlock the power of the stars, and in doing so, illuminate a future of sustainable prosperity for generations to come. As always, thank you for watching. If you liked what you heard, please consider subscribing. If you did not like what you heard, thank you for sticking with me this far. No matter who you are, you only get 24 hours in a day. Thank you for spending a portion of that with me. See you next time.